So let's resolve a vector into x and y component. So I have a vector A that makes an angle theta with respect to x-axis. Okay. So here the component of A along x-axis is called x component, and the component of A along the y-axis is called the y component. Okay, so my goal is to find AX and AY. So let's start with that. So AX is the x component of vector A, and AY is the y component of vector A. One important concept here is remember that if you just write AX, that means we are talking about only positive value or only the magnitude only. But if you write AX overhead arrow symbol, that represents a vector. Okay, so this is a slightly different way to express vector and scalar. So let's start to find those components. So in this triangle, I can use the Pythagorean theorem. So sine theta will be AY over A. I multiply both sides by A. This A cancel out. So AY equals A sine theta. So that gives you Y component. Let's start to find the cosine theta. So cosine theta will be AX over A. Again, if I multiply both sides by A, that cancel out. So AX equals A cosine theta. So we can find X and Y component by this way. Okay. So now let's divide these two equations. So if I divide, say AY A sine theta over AX A cosine theta, what will happen? The A cancel out. That gives you AY over AX. Sine over cosine theta is tan theta. So you can get theta equals to tan inverse AY over AX. So this is just doing the algebra a few steps. Similarly, by trig is clearly A squared equals AX squared plus AY squared. So by using the trig, we can find the x and y component of any vector. So the step to remember is that AX equals A cosine theta and AY equals A sine theta, but be careful that this angle theta is with respect to x-axis. If you do for the y-axis, they will flip. Okay. So let's use this concept for the example 1. So here vector is 15 meter at 30 degree with x-axis. So vector A, if you just write A without a vector symbol, this is a scalar number, 15 meter and theta is equal to 30. So I can use the similar concept here. So you can look at here, this is y component, this is your x component. Okay, so you can use this previous concept of SOHCAHTOA. So sine theta equals AY over A. Again, I multiply both sides by A. This A cancel out. So AY will be A sine theta. A in this case is 15 meter and sine 30 degree. Then this gives you 15 times sine 30, which will be 7.5 meter. Okay, so you get AY is 7.5 meter here. So AY is 7.5 meter. Your A is 15 meter. Your angle theta is 30 degree here. Let's find the x component. So for x component, I will use cosine theta. Cosine theta equals ax over a. As before, I multiply both sides by a. This a cancel out. So ax equals a cosine theta. So a is 15 and cosine 30 degree equals ax. So ax equals 15 times cosine 30, which will be close to 13 meters. So it is 13 meter. So clearly you see that ax plus ay, which is 13 meter, plus ay is 7.5 meter, is not equals to a, which is 15 meter. Okay, so be careful about vector addition also. So this gives you the idea that vector addition is different from the scalar addition. I believe that once you understand this concept, you can use the similar concept to solve this problem. Also, you can use the OP physics to play with. Say, for example, I have vector of say 50, or I can change the number over here. You can see that 50, I can change the angle 50, right? Or you can go to the different angle. Say if I go to angle, say 20 degree, then your AX will be 47, your AY will be 17.1. If you do the similar step, you will get the exact same number. Or you can play with different things. Say you have bigger vector, A is 140, you can change the angle, say 162. So for example, this angle is measured from positive x-axis. Okay, so in this case, your x component is 133.1 and your y component is 43.1. So this is also a tool to play with and get the concept. Okay, so feel free to ask any questions during the class.